This AMC Jeep dealership training film is unlike any other you might have seen. I don't know much about the operation, diagnosis, or repair of anything on AMC cars or Jeep vehicles, but I do know about measurements. I know what you need to know about the modern metric system of measurements. Metric measures, of course, are now being used worldwide, and the U.S. is currently in the process of changing over to metrics. You've seen these metric measurements showing up more and more in your technical service manuals, and many fasteners, components, and specifications are already metric. For instance, our new 2.5-liter four-cylinder engine is outfitted with metric fasteners. Some other components using metric fasteners include the 10 SI alternator, the tie rods for both AMC cars and Jeep vehicles, and our newest power steering systems. And you'll soon be seeing metric measurements used for such specifications as braking distance, engine torque, fluid capacity, road speed, vehicle weight, temperatures, fuel consumption, and various pressures. In the coming years, you won't be working with measurements such as inches, pounds, gallons, or degrees Fahrenheit. Instead, you'll be working with metric measurements such as millimeters, kilograms, Newton meters, kilopascals, liters, and degrees Celsius. This film will prepare you for using metric measurements. We'll talk about metric measurements for length, weight, torque, pressure, volume, and temperature. And we'll talk about some of the metric tools you'll be using in your work. These include the metric ruler, micrometer, and dial indicator. After various learning blocks in the film, you'll be asked to complete a brief quiz in your reference booklet as a quick check of what you've learned. A label projector will automatically stop at each of these checkpoints. If you are using another type of projector, you will have to manually stop the projector. Let's begin learning about metrics by checking your basic knowledge of this measurement system. Open your reference booklet to checkpoint number 1 on page 1. Do your best to answer the 5 questions. When you are finished, start the projector and check your answers. Okay, how did you do? 1A is correct. The meter is the metric unit for linear measurement. The Newton meter is the metric unit for torque. So, 2C is the right answer. Then, 3B, the air pressure in a tire would be measured in kilopascals. D, 0.01 km is the largest measurement of the choices in question 4. And last, for question 5, B is the right answer. A metric micrometer can be used to measure thickness in millimeters. Don't be alarmed if you missed a few. By the end of this film, questions such as these will be easy to answer. I just wanted to get you thinking metric and to prepare you for the topics we'll be covering. So, let's now talk about the metric measurements for length, weight, torque, pressure, volume, and temperature. First, we'll tackle length. The base unit for length in the metric system is the meter. It's slightly longer than a yard. How did anyone come up with this length? Well, the meter was originally defined as 1/10,000,000th of the distance from the North Pole to the equator through Paris, France. In other words, that distance was 10 million meters. Unlike our sometimes confusing system of measurement, the metric system is scientific. It is based on the decimal system, with easy-to-remember multiples and submultiples of 10, 100, and 1,000. Metric prefixes are used with the base unit to indicate larger or smaller units. For instance, kilo means 1,000, centi means 1/100th, and milli means 1,000th. Here are the most common metric units of length, as well as their symbols or abbreviations. Kilometer is symbolized by the lowercase letters km, meter by m, centimeter by cm, and millimeter by mm. The prefix tells you the size of the unit. For instance, 1 kilometer equals 1,000 meters. 1 centimeter equals 1/100th of a meter, or 0.01. 1 millimeter equals 1/1000th of a meter, or 0.001. By using the right prefix, you can form measurement units for almost anything. Kilometers are used for measuring long distances. AMC Jeep speedometer graphics show kilometers per hour, and highway signs are being changed to show distances in kilometers. 1 kilometer is about 6/10 of a mile. Meters are used for measuring turning circle radius and for measuring braking distances. Centimeters in our business are used in general dimensions of vehicles, as well as for describing glass and fabric areas. Millimeters are the units you will work with most. Spark plug thread sizes are given in millimeters, metric fasteners are in millimeters, and metric wrenches and micrometers also use millimeters. There's a simple rule to follow when going from one unit to another. Move the decimal point the appropriate number of spaces to the left or right. For instance, 1 meter is 1/1000th of a kilometer, 100 centimeters, and 1,000 millimeters. Now, let's check what you've learned about metric measurements for length. Please open your reference booklets to checkpoint 2 and answer the 7 questions. If you're in doubt about 1 or 2, look over the information that precedes the quiz. When you are finished, start the projector and check your answers. Here are the answers. Did you learn something? The base unit for linear measurement in the metric system is the meter. 1/1000th of a meter is a millimeter. The prefix kilo means 1,000. cm is the symbol for centimeter. 1 centimeter is equal to 10 millimeters. 850 mm is equal to 85 cm. And last, 35 centimeters is equal to 350 millimeters. You should have gotten a perfect score. If not, review your reference booklet to see where you went wrong. Now, let's talk about some other metric measurements. How about weight? That's something all of us are usually worried about. The base unit for weight in the metric system is the kilogram. It's slightly heavier than 2 pounds. The kilogram is the only metric base unit that has a prefix as part of its name. Kilo, of course, means 1,000. So a kilogram is 1,000 grams. The metric symbols are kg for kilogram and g for grams. Vehicle weights and load ratings will be expressed in kilograms. Next, I'll talk about torque in the metric system. You work with torque specifications every day in your job. Torque, of course, is defined as applying a certain force to a lever arm to rotate an object about a point. In the metric system, force is expressed in newtons, and the length of the lever arm is expressed in meters. So, the unit for torque in the metric system is the Newton meter. Metric torque wrenches are calibrated in Newton meters, so torque can be read directly on the dials of such wrenches. The metric symbol for Newton meter is capital N, small m. Some typical torque specs are 30 Newton meters for spark plugs and 130 Newton meters for head bolts. A typical AMC 6-cylinder engine develops about 285 Newton meters of torque at 1,800 RPMs. Pressure is another important specification in your work. So, let's see how pressure is handled in the metric system. Pressure is force per unit area. In metric terms, force is in newtons and area is in square meters. So, pressure is actually the force in newtons per square meter. But to simplify things, the metric unit for pressure is the pascal. 1 pascal of pressure equals 1 newton of force per 1 square meter of area. The symbol for pascal is capital P, small a. 1 pascal is a very small amount of pressure, so you will normally use kilopascals, or kPa, in your work. 1 kilopascal equals 1,000 pascals. Some common examples of pressure in kilopascals include 90 kPa for a typical oil system pressure, 190 kPa for tire pressure, 1,000 kPa for engine compression, 8,000 kPa for a hydraulic jack, 30,000 kPa for brake line pressure. There'll be changes in how you think about volume, too. Volume is used to measure the amount of space occupied by solids, liquid, and gases. Various units are used to express volume in metric terms. For instance, luggage capacity is in cubic meters, engine capacity in liters, some fluid capacities in cubic centimeters. In service, you will most often work with the liter. A liter is about 5% larger than a quart. Our new 4-cylinder 151 CID engine has a capacity of 2.5 liters. A typical 22-gallon fuel tank will hold 83 liters of gas. A typical automatic transmission needs about 8 liters of fluid. And a typical cooling system for a 6-cylinder engine will hold about 13 liters of coolant. Also, here's something interesting. We won't be talking about miles per gallon anymore. Instead, fuel consumption will be measured in liters per 100 kilometers, oil consumption in liters per 1,000 kilometers. The last metric measurement that we'll talk about is for temperature. In the metric system, a temperature of 0 degrees is assigned to the freezing point of pure water, and a temperature of 100 degrees is assigned to the boiling point of water. The scale is then divided into 100 equal parts. This is called the Celsius scale and is marked in degrees C. Here's how the scale compares with the Fahrenheit scale that you've been using. Degrees C are larger than degrees F, so you'll be seeing smaller numbers in your service specifications. For instance, antifreeze protection on new vehicles is set at about minus 30 degrees C. Your body temperature is about 30 degrees C. An EGR CTO switch is rated at 46 degrees C, while the Spark CTO switch is rated at 65 degrees C, and a typical thermostat rating is 90 degrees C. And that's it. We've covered 6 key metric measurements, those for length, weight, torque, pressure, volume, and temperature. You should now have no trouble using them in your service work. But just to make sure, let's have a quick review of what you've learned. We'll do it with another brief quiz. Please open your reference booklets to checkpoint 3 and answer the 6 questions. When you're finished, start the projector and check your answers. Here are the answers. Did you get a perfect score? I hope so. Of course, spark plug thread sizes are given in millimeters. The base unit for weight in the metric system is the kilogram. A typical torque spec for spark plugs is 30 Newton meters. Kilopascal is the unit you work with for pressure. 1 liter is about 5% larger than a quart. And for number 6, degrees F are smaller than degrees C. If you missed any, you must have been thinking of something else while I was talking. If so, you'd better keep your reference booklet handy for future use. Now, let's talk about some of the metric tools you'll be using in your service work. We won't spend a lot of time on these, just enough to give you a basic understanding of their use. Here is a metric ruler or scale, which is used to make measurements on flat surfaces. This ruler has 3 sets of marks. The smallest marks are half millimeters and full millimeters. There are 10 millimeters for each of the large numbered divisions. These marks must be, that's right, centimeters. How long is this wire clamp? Right again. The wire clamp is 2.3 centimeters or 23 millimeters long. You can use a metric ruler to measure the bore of a cylinder. Most service jobs, however, require measuring tools that are more accurate than a ruler. One such measuring tool is the metric micrometer. It can measure accurately to 1/100th of a millimeter. The micrometer has 5 basic parts. These are the anvil, spindle, frame, barrel, and thimble. When you turn the thimble, it moves along the barrel, and the spindle moves toward the anvil. The micrometer has 2 scales. The first scale is stationary on the barrel and is called the main scale. The second scale is movable and is called the thimble scale. The main scale gives readings accurate to 1/2 millimeter. The marks above the line indicate full millimeters, while the marks below indicate half millimeters. The thimble scale gives readings accurate to 1/100th of a millimeter. There are 50 lines or divisions on the thimble scale. Each represents 1/100th millimeter, so all 50 add up to 1/2 millimeter. It takes 2 full turns of the thimble to move it 1 full millimeter. Here's how you take a reading with the micrometer. First, read the main scale to the nearest 1/2 millimeter. Second, read the thimble scale. Third, add the 2 values for the total reading. What is the value on the main scale? Right, it's 14 millimeters. Now, what is the value on the thimble scale? Yes, it's 25/100ths of a millimeter. The thimble scale is read at the horizontal line on the main scale. Can you figure out the total reading on this micrometer? I hope you came up with 21.90 millimeters. You should have read 21.5 on the main scale, then added 40/100ths from the thimble scale. You'll get a chance to test your knowledge of reading a micrometer in an upcoming checkpoint. But for now, let's quickly move on to another important tool in your service work. It's this handy little device. I'm sure most of you recognize it as a dial indicator. An excellent tool for measuring crankshaft play, cylinder wear, and other out-of-round conditions. I won't go into all the details of how a dial indicator is used. You probably know how to use one. I'll just talk about how you read a metric dial indicator. First of all, like the micrometer, the dial indicator is accurate to 1/100th of a millimeter. It has 2 needles, a small needle and a large needle. The small needle counts full millimeters. The large needle counts 1/100ths of a millimeter. There are 100 lines or divisions on this scale, so 1 complete revolution of the large needle would be 1 millimeter. To take a reading, you simply read the small needle scale, read the large needle scale, and then add the 2 values for a total. The total reading on this dial indicator is 2.91 millimeters because the small needle is registered between 2 and 3 millimeters, and the large needle points to 91/100ths of a millimeter. On this dial indicator, the small needle is between 5 and 6 millimeters, and the large needle is pointing to 63/100ths of a millimeter. So the total reading is 5.63 millimeters. And now, let's check your knowledge of the metric micrometer and dial indicator. Please open your reference booklet to checkpoint 4. Again, answer the questions and then start the projector to check your answers. All finished? Just check your answers with those given here. The first micrometer reading is 4.83 millimeters. The second, 11.40 millimeters. The third, 15.65 millimeters. Then, for question 4, the dial indicator reading is 8.75 millimeters. And that's it for this training film. I hope I've been a good teacher, that you now have a better understanding of metric measurements. Someday, I might check up on you. And what would you say if I told you I was a perfect 92, 60, 92? Do you get the idea? It would be a shame if you didn't know what I was talking about. Metric measurements are here to stay. And I hope you know that the 3 I just gave you were in centimeters. Thank you for your time.